And again, you can start with whichever test you want. It's no specific order. Me, I'm just a creature of habit, so I always start with power over 2. Okay, so with theta equals power over 2, remember you replace r theta with negative r negative theta. Okay, so that means our r becomes negative r equals 4, and instead of cosine squared of theta, I'm just going to rewrite it as cosine theta squared, or negative theta squared. Minus 3 times sine of negative theta plus 5 of negative theta. Okay. Oh, let me make that a little bit darker. Okay. Now we know that sine is an odd function. We also remember that cosine is an even function. So just a quick little side note. So cosine of x is an even function. So when it's an even function, that means f of negative x is equal to f of x. That means cosine of negative theta is equal to cosine of theta. Okay, so that means we have negative r equals 4 times cosine of theta squared. So we're going to move that back over there. Remember, that's an odd function, so that negative just goes out to the front. Plus 3 sine of theta. And that's just 5 times negative theta, so you can just move that negative 1 right out to the front. Just another little reminder, side note. Sine of negative theta equals negative sine of theta. Because it is odd. All right, so now we really just want to solve for r, just to see if it matches up to where we started. Yes?
With that negative theta and the cosine squared, so that negative goes away simply because it's an even function, not because it's squared?
Yep, just because it's even.
Okay.
And plus, if it's squared, it would have gone away too.
Right.
So if you had sine squared, it would have been negative sine squared, which it would have gone away.
Anyways.
Yeah.
When we distribute now, it's going to go back to where it was.
Yep, exactly. So once you divide or multiply both sides by negative 1, you have r equals negative 4 cosine squared theta minus 3 sine of theta plus 5 of theta. Where it's close, but that first term is a little bit different, so it's not equivalent. So. Okay, so we know it's not symmetric across pi over 2. Okay. So now we can go ahead and try the polar axis. Okay, which means that our theta is replaced with our negative theta. Okay, so that gives us r equals 4, and we already know cosine squared is going to give us cosine squared, but I'll write it out anyway. Cosine negative theta squared minus 3 sine of negative theta plus 5 of negative theta. And again, that just gives us cosine squared theta. That being odd is going to bring that negative up to the front. So that's plus 3 sine of theta. 5 times negative theta, we just bring that negative 1 right out front. Okay. So again, close, but that middle plus sign kind of throws everything off. So again, not equivalent. Which means it's not symmetric across the polar axis. And why I put parentheses around axis, I have no idea. Okay, so now we try symmetric across the pole, or origin. Okay, so that's r theta. You're going to replace that with negative r theta. Okay, so that gives us negative r equals 4 cosine squared theta minus 3 sine of theta plus 5 of theta. Divide both sides by negative 1. That changes all the signs. We'll bring that up some. Which is completely different. So we know that's not symmetrical, or not equivalent, and not symmetrical. Okay, so in this case, it's not symmetrical with anything. So it's possible it could be symmetrical with 1 or none.
It'll never be just symmetrical with 2 of them, right? It's either
It's
1, none, or all 3.
I've never seen one symmetric with 2 of them. I'm not saying it doesn't exist, but
Right.
you probably won't run across them
Okay.
in this
'Cause I was just
section.
wondering, like, if we're doing this on a test or homework or
Mhm.
something, if we get like symmetrical for 2 of them, can we just write symmetrical with all 3 without testing the third? Because if
It would.
it can be 2 out of 3, I guess we do have to do all 3.
Yeah, it
Okay.
could be. Like I said, there's circumstances where it could be all 3. I can't remember one where it was 2 out of the 3. I'm not saying it doesn't exist. I just personally haven't seen it. So
I guess if you're running short on time,
exactly.
you could probably chance it.
Yeah. All right. Any other questions on this one? All right. Anyone still writing? All right. Okay, so now we're going to look at the zeros. Or pole equation. Now these are kind of a throwback to trig, so if you're rusty, you may want to go brush up on your trig a little bit. But the actual steps as far as getting started is not that far from what you've done before. So remember the zero of a function. Let's say we want to find the zero of f of x equals ax cubed plus bx squared plus cx plus d. Just any random third degree function. We said f of x equals 0. Bless you. Which means we have ax cubed plus bx squared plus cx plus d equals 0. And we solve for x. Okay. So for polar equations, you pretty much do the same thing. You set r equal to 0 and you solve for theta. So the process isn't completely new, just kind of a little bit of a twist to it. All right, so let's say, for example, now I'll start on a new page, just in case. So I'll have to squeeze everything on the bottom. Right. So let's say, for example, say what are the zeros of the polar equation? R equals 4 cosine of theta plus 2. So all we have to do is set r equal to 0 and solve for theta. Okay, so that gives us 4 cosine theta plus 2 equals 0, which if we subtract 2, divide by 4, cosine of theta equals negative 2 over 4, which is just negative 1/2. So if we apply cosine inverse to both sides, theta equals cosine inverse of negative 1/2. Or actually, you could have left it here since it kind of gives you an idea of what you're looking for. But whichever step you're comfortable at, you could have stopped there. Okay, now remember, cosine of pi over 3 is equal to positive 1/2. Okay, now that much we know. And we also know that x is equal to r cosine of theta. But in this case, since we don't have a radius in front of the cosine, we kind of pretty much went with the unit circle. We know that x is equal to cosine of theta. Uh-oh, clean that up a little bit. Okay, so now since we know what our positive 1/2 is, we have to figure out what our negative 1/2 is, which means we have to go back to our reference angles and all that other stuff. Okay, now in quadrant 1, our reference angle is just equal to our angle. Nothing changes. Now in quadrant 2, uh-oh, wrong one. I know. Thing is, I did it when I was writing the notes out too. I erased like 5 times. Okay, so our reference angle is equal to pi minus our angle.